Madin 2000 is a leading rotor dynamics software developed by Delta.js. Fluid film bearings are the most common bearing type in high-speed turbomachines and are an essential component of the rotor dynamic model. Madin 2000 offers a wide range of modeling and analysis options for radial fluid film bearings. The geometry of all relevant bearing types can be defined by the user in the bearing GUI. Hydrodynamic pockets can be added to fixed pad bearings. This feature can be used to model, for example, a pressure dam. For turbocharger models, there are full and semi-floating ring bearings with 2 oil films. Madin 2000 includes comprehensive analysis options for the calculation of linear and nonlinear bearing data. The non-synchronous coefficients of tilting pad bearings can be calculated, which can affect the rotor stability. And finally, there is the option of importing bearing data from third parties. First, we show how to model and analyze a tilting pad bearing. After specifying diameter, axial length, relative clearance and preload, the type tilting pad is selected. The number of pads is set to 4 and the default load on pad configuration in the pad GUI is turned by 45 degrees to have the vertical load between the pads. The default start and end angles of the first pad are adjusted and the values copied to all other pads with one command. Now the bearing geometry is defined and can be plotted. The oil type must be selected and the inlet temperature specified. The analysis type is set to the DIN table method, which uses laminar flow and an equivalent mean oil viscosity. This method requires a suitable reference temperature for the calculation of an initial bearing table. As load, we enter the rotor speed range and a constant static vertical force. In order to get also the frequency-dependent non-synchronous coefficients, we tick the corresponding checkbox and then start the linear calculation. The results of the bearing analysis can be printed, saved as a file, or visualized with plots. There are 2 basic result plots. The plot of the static load and the shaft center position as a function of the rotor speed, and the plot of the synchronous stiffness and damping coefficients as a function of the rotor speed. The non-synchronous coefficients can be plotted as a function of the frequency for each calculated rotor speed. In the second example, we show how to add a pressure dam to a cylindrical bearing. A pressure dam is sometimes used in cylindrical bearings with low static load to improve the rotor stability. In the existing model of a cylindrical bearing with 2 pads, we open the pad GUI, select pressure dam from the hydrodynamic models and move to the upper pad. The geometry of the pressure dam is described by the end angle, the width, the depth and the axial position. After specifying this data, it can be checked in the clearance plot if the pressure dam has the intended dimensions. The third example is a cylindrical bearing with 2 hydrodynamic pockets. The hydrodynamic pockets with a depth of 0.2 mm are located adjacent to the oil inlet pockets and can be visualized with a clearance plot. For this bearing, we look at the 2D field plots of the bearing analysis results. After choosing a combination of rotor speed and static bearing load, a user-configurable GUI can be opened and the desired result items selected. Availability of the results depends on the bearing analysis type. In the first sample plot, 3 basic result items provide a quick overview. In the second sample plot, details of the oil flow are documented. In the third sample plot, different temperature results are shown. The fourth example bearing is a closed bearing. This bearing type is typically used in vertical pumps. Water is among the available lubricants. The lubricant flow through the bearing is in axial direction and requires a pressure difference across the bearing. In a vertical machine, there is normally no significant static force on the radial bearings. In such a case, only nonlinear rotor dynamic analysis can yield meaningful results. For this purpose, the nonlinear bearing characteristics can be calculated in Madin 2000 and are then available for the nonlinear transient analysis. The coefficients are calculated for all possible shaft center positions in radial and angular direction. Among the available result plots are the bearing forces due to the journal rotation and due to the journal velocity. For symmetry reasons, the results are only shown for one of the four segments. But in 2000 includes many more features for sophisticated fluid film bearing models. If you are interested in our advanced rotor dynamics software, you can contact us for more information.